So we're going to take a look at deployment methodologies for Elastic Beanstalk, and you're going to notice that down below I have blue-green. So we never covered blue-green as of yet. And so these have all been mutable all the way to all at once have been deployment policies. These are built-in deployment methods into Elastic Beanstalk, but we have blue-green. And we'll explain the difference between in place and blue-green in the next slide here. But let's just compare these methodologies and understand what the trade-offs are, because this is definitely important on the exam. So the first one is all at once, and it has the fastest deploy time because it updates all the servers at the exact same time. So if we have 4 servers, it takes them out of service, applies the updates, and puts them back into service. But when they're out of service, we're going to experience a downtime. And downtime could be a bad thing if your users notice, and that could impact their experience, or if they're doing serious or critical transactions, that could be a problem. So you have to decide whether that is a trade-off you want to take, but most people do not want to use all at once. And also, if you encounter an error, let's say your deploy fails and you have 4 servers, now you have to roll them back manually. And so that's kind of a pain. But also, imagine if you encountered an error during rollback, so the rollback fails, and now you have 4 servers all stuck in a broken state. That could be extremely detrimental to your business, losing hours upon hours of time. So you have to weigh those trade-offs. Now, next we have is rolling. And so rolling mitigates this downtime problem where we have instances that are out of service. So what it does is, so if you have 4 servers like the previous case, it's going to update these in batches. So it's going to take the first 2 and take them out of service, right? And then put them back into service, and then it's going to move on to the next one. But the trade-off, there is still a downside, which is we're going to have a reduced capacity. So if you have to have always 4 servers to run your critical workload or to just handle the current usage, this is not going to be ideal for you. So what you're going to want to do is you're going to want to use rolling with additional batch. So rolling with additional batch is very similar to rolling. So it's going to work in batches, but instead of taking a batch out of service, it's going to add a new batch. And once this one is good and running, it just kills an old one. And so this way you always have at least the minimum amount of servers you need running to meet your capacity needs. But rolling back for these methodologies can be difficult. It's still a manual process, and you could just imagine having to roll each section back could be painful. Imagine that you're rolling this back and then this rollback fails, and now this one's stuck into a state. So you have a weird number of servers messed up here. This can be extremely difficult. So the last one here is immutable. Immutable, the idea is you just replicate your entire environment. So like all at once, if you had 4 servers, it would take them out of service. With immutable, it would just create 4 new servers. And once they're all good, then you could move over to those 4 new servers. And if you had to roll back, you just point back to the old ones because they still exist, because they haven't yet been deleted until you decide to do so. So immutable gives you the best flexibility in terms of the rollback process. It can be more expensive depending on how long you keep those servers around. The provisioning time takes a long time. The actual switch takes very little time because it's very fast to roll back or switch to the new version. But to provision those servers take a while because you're replicating everything at once, and before you can actually start routing traffic to it. Because with rollbacks, you can start with rolling, you can start routing traffic to new instances gradually or immediately, whereas immutable, you have to wait till all the servers are ready. But I think immutable is extremely safe and a good deployment methodology to use. And then last we have blue-green, and blue-green is very, very similar to immutable, where it will replicate all the servers. So if you have 4 servers, it's going to make 4 new servers, but also it could spin up other infrastructure like Elastic Load Balancers and stuff like that. But these are super, super similar, and that's why we have another slide to talk about them, to understand when something's in place versus blue-green. But just before we move on here, for Elastic Beanstalk, the blue-green methodology uses a DNS way of doing blue-green. So that means that when you want to move over to these new servers, it roughly 3 points to a new load balancer. So there's a new load balancer with new instances on it. And so the change is happening at the DNS level. And the reason why this can be a negative is that DNS changes have to propagate to DNS servers around the world. And the effect that could happen is that you could have this new production server ready, but people are still being pointed to the old one, or it's going nowhere. And so even though the server's not down, there could some users could experience unavailability just because they're being pointed to the wrong thing. So that is a consideration you have to think about. Though for Elastic Beanstalk, it's not generally that bad, but it does happen. So we do have to consider that as a negative. But now that we know deployment methodologies, let's move on to the comparison between in-place and blue-green. So let's take a look at in-place versus blue-green deployment here. And these terms are confusing because they're not definitive in definition, and the context can change the scope of what they mean. So it's important to learn these not just for Elastic Beanstalk, but for DevOps in general. So we're going to spend a little bit of time here making sure you really know this stuff inside and out. So Elastic Beanstalk by default performs in-place updates, and that's all the deployment policies we've been looking at. They've all been considered in place. But let's change the context to see how that affects the scope, which will change what is considered in place. So the first we're going to look at, which we're already familiar with, is with the Elastic Beanstalk environment. So when that is our scope, that means that all the policies we saw prior, all at once, rolling with additional batch, and immutable, are considered in-place deployment methodologies. So let's say we change the scope to outside of Elastic Beanstalk, and now it's just servers. So we have these servers, but what's really important is that these servers are never replaced. So they always have to be the same servers, the existing servers. So that's our scope. And now the only deployment methodologies that are available to us is all at once or rolling, which are considered in place because they never replace a server. They'll take a server out of service, make changes, and put it back into service. Now, that doesn't mean that rolling with additional batch and immutable would be considered blue-green. They just wouldn't be considered in place for the scope of that scenario. Let's set up another one where the scope is now we have a server that can never be interrupted. So it doesn't mean that means we can't replace the server with a new server, but that also means we can't take it out of service. So it should never lose traffic. It should always be traffic should always be pointed to it. And so to solve this, we'd use zero downtime deploys. This is where blue-green occurs on the actual server itself, like in a virtual sense, where you have your code base and then you deploy the second version of the code base on the server, and then you facilitate the change, the switch within the server virtually. And you can't do this on Elastic Beanstalk. I used to do this for years with Capistrano, Ruby on Rails, and Unicorn. And this allows for deploys that happen within minutes. So like in 30 seconds or 1 minute, I'd have the latest version updated. It was amazing. But when we have to consider all these cloud components, this kind of agility has been lost, but we get other kind of trade-offs to it. So, that's the stuff that we're looking at. But when we're talking about the exams itself and they're talking about in place, they're going to be talking about generally in the context of Elastic Beanstalk environment. So I just want you to know the differences of this. But for the exam, this is the one you're going to focus on for in place. Okay. Okay, so this is the slide where everything is going to fall into place, and you're going to really understand the difference between in place versus blue-green deployment. So this is going to be in the context of Elastic Beanstalk, and we're first going to look at an immutable deployment methodology. So we know with immutable that what happens is it replicates the auto-scaling group with another EC2 instance, and then it facilitates the transition to the new production servers by switching over to this auto-scaling group and then destroying the old one. Now, this is funny because in our last slide, we just saw that there was a blue-green methodology called ELB blue-green, and this is exactly what it did. So why isn't this considered blue-green? And it's called in place. And that has to do with the boundaries of the environment. And so the environment is defined here as being the Elastic Beanstalk container. And so because the mechanism of our deploys inside the boundaries of this environment, it's considered in place because it's inside of the environment. So now looking at a blue-green deploy, For Elastic Beanstalk, this can only occur at the DNS level. So it's Route 53 that's facilitating it. But notice that it's outside of the environments. It's outside of it. It's going from a blue environment to a green environment. And so that is why it's called blue-green deploy. If it's all within the same environment, it can't be considered blue-green. So, talking about doing a DNS, like having the DNS level facilitate the switch of servers, or having the load balancer, I was saying the load balancer was a lot better because with DNS, we could have an interruption in service, not because the servers aren't ready, but like the DNS servers have to propagate the changes, and so there could be some unavailability for servers. So why would you still use this then if this one is better? And this has to do with where some of your external resources lie. So in the context of Elastic Beanstalk, it really has to do with your database. So if you are using in-place deployment, a lot of them are very destructive. So your database would be inside of the environment. It would be running on an EC2 instance, generally. And, it would get terminated with the environment. And so you'd lose your data. So that would not be good whatsoever. So your database would have to sit outside of your environment, like on RDS. And so, the better place to do it would generally be with a blue-green deploy with your database outside of it. So that is generally the reason why we use blue-green. That doesn't mean you can't use RDS within place, but generally it's more for blue and green deploy. So hopefully that clears up a lot of stuff, and you can understand and visualize those boundaries to see when something's in place and when something is not considered in place. So if we want to change the way our Elastic Beanstalk environment works pragmatically, then the way we're going to do it is through configuration files. These configuration files sit in a hidden folder called EB extensions at the root of your project, and they're going to have an extension that says .config on them. So there's going to be a variety of different ones, but that's what Elastic Beanstalk expects. And what we can change to these configuration files is the option settings for our initial environment. We can do things very specific to Linux and Windows. And then we can also set up custom resources. So if we need other AWS services to integrate, that's what we can do there. But the motivation of having this file here is that, let's say we want to hand this project to somebody else, they can just provision all the things they need with the exact configuration they need. So this is something you'll definitely run into if you're working on Elastic Beanstalk. You'll have to do a little bit of configuration. So I said that you could configure some option settings for the Elastic Beanstalk environment, and that's called the environment manifest, which is in a file called the env.yaml, and you're going to store that at the root of your project. So this file is important because when you first create your Elastic Beanstalk environment, it's going to look for this file and set up a bunch of defaults. So this is the way that you're really sharing that configuration with other people, or just saving that configuration for yourself. So what I've done here is I pulled out a little example, and we're just going to look at some of these attributes here. So the first one that we're looking at is the environment name. So that's whatever you want the name to be, and we'll talk about what that plus is in a moment on the end there. Then there you have your solution stack, so that could be Ruby, Python, Java, whatever, but that's going to be what AMI is chosen. Then you have environments links, and this associates to other environments. So we saw that you could have a web environment and a worker environment, and so this is a way to connect them together. And then you have some default configurations for specific AWS services. So here we are setting a load balancer to be cross-zone. And there is a lot more options here, but we don't need to go through all of them. You just have to generally know that you can do this stuff. And let's just talk about that plus there on the end. So that plus is used to add the environment name to the end there. So to give these more unique names. So that's all that thing is for. So there you go. So now we're going to take a look at Linux server configuration. There is one for Windows server configuration, but I think we only need to really learn one here because you can pretty much apply this to both, and that'll be good enough for our studies. So the first thing you could configure is being able to download packages. So here I have Ruby, or we have Memcache. I think the package manager will generally be Yum because that's what AWS uses for both Amazon Linux 1 and Amazon Linux 2. If you can use some kind of other OS, that might change to something else. Then you can set Linux Unix groups, something I don't do very often, but something you can configure. Then you can also configure users and assign them to Linux groups. You can also create files or download files from the internet using a URL. That URL is for public-facing files, so I don't think there's a way to download private files. But for the content, you just specify content and provide what you want. There, I'm providing a YAML file. Then you have commands. These are commands that you want to run before your application has been installed. So Elastic Beanstalk pulls your code base, but this happens before that code is actually in the environment. Then you have services. So maybe you've installed Nginx and you want to ensure that it is running when it starts up, and it continuously runs. So if for whatever reason it shuts down, it will try to make it start up again. And then the last thing are container commands. And so these are commands that are specific to your application. So after your application or your source code has been downloaded to the environment, these are what you want to run on it. It says container commands, which make you think that these are for Docker containers. That's not the case. So just be aware of that. But for Windows, you're going to have similar ones. So you'll have container commands, commands, probably something for packages and files. So it's more or less similar. It's just as long as you conceptually understand the things you can set at the server level. So Elastic Beanstalk has a CLI which you can install, and that's going to give you more of a Heroku-like experience. And you're going to notice some of these commands are very similar to Heroku commands. So to get the CLI, you need to go to GitHub and just ahead and install it. So it's just as simple as cloning the repo. And I believe this is using Python. And so you just execute that command. If you're on a Mac, this should just work. For other systems, you're going to have to read a little bit more on the GitHub page itself, which you can see is at the AWS Elastic Beanstalk CLI setup there. But let's just run through some of the commands that are available to us, starting with init. So this configures your project directory in Elastic Beanstalk CLI. This is the first thing you're going to want to run because it's going to set up a bunch of defaults on your computer. And if you don't want to make a project, you can just delete that project afterwards, but you still want to run this. When you want to create an environment, you're going to be doing create. When you want to check the status of an environment, you're going to do status. When you want to check the health, you can get health on the particular instances and the overall health of the environments. If you want to get that in real time, or near real time, you can do a refresh and it'll update every 10 seconds. If you need to see a bunch of events that are being outputted by the Elastic Beanstalk environment, you can run that. If you want to see logs from the actual instance yourself, you can run logs. If you want to open up the application in your browser, there's open, but it's really not that hard to do. You could just go to your browser. When you're ready to deploy your current version of code, you do deploy. If you want to see what kind of configuration setup you have for that environment, seeing whether it's running Ruby or other options, you can check that as well. And if you want to terminate that instance because you want to save money, you can do terminate. So go ahead and download the CLI and give it a go. So we're going to look at how you can use your own custom image in Elastic Beanstalk. And this is where you can provide your own AMI instead of the standard Elastic Beanstalk AMI of your choice. The reason why you'd want to do this is because it could improve provisioning time. So if you have a lot of software, like packages you need to install to run your software, it takes a long time to pull all those. If you bake it into an AMI, it's just going to speed things up because it's already there. So let's go through the process of how you'd actually get a custom image, because it's not hard, but there's a lot of steps to it. So the first thing you're going to want to do is go to AWS Docs. There's a page called supported platforms, and you get a list of all the type of standard Elastic Beanstalk AMIs. And what you're doing is you're trying to get the platform information there so that you can then use the CLI to use this command called describe platform version. And so by using describe platform version, and you can see over there, it has the platform name in it, it's going to get us back an image ID. And that image ID is the the AMI's ID so that we can then find the AMI and then extend that AMI to do what we want with it. So using that AMI ID, you'd go to the EC2 marketplace, probably into the community section, and you'd paste in that AMI. So we would find the AMI we're looking for, and then we would launch a new EC2 server. Once that EC2 server is launched, we could then log into it either using SSL or Sessions Manager. I would suggest Sessions Manager to do so. You would need the correct IAM role attached to it, so just be aware of that. But once you get into that machine, you configure it however you want. So you'd go in and you'd install those packages manually, and then you would go ahead and bake that AMI, and so you'd have your new AMI. So once you have the new AMI, you could go in your configuration, like your files, or you could even do it through the console and set the new AMI ID. And then when you create new environments, that's what it's going to use. So that is the whole process to setting up a custom image. So we need to talk about configuring your RDS database with Elastic Beanstalk, because you actually have two options. You can add a database inside or outside your Elastic Beanstalk environment, and you might not even be aware that you're doing it if you're setting it up. So it's important to know the difference. So let's talk about inside the Elastic Beanstalk environment. So when you go to create an environment through the console, you'll have the option to create a RDS database. And if you are doing that, that means it's going to be within the Elastic Beanstalk environment. Now, the thing is, if you do this, that means whenever this environment is terminated for any reason, it will take out the database with it. So that means that generally this setup is for development environments. That doesn't mean you can't use it for production, because as long as you're using in-place deployment mechanisms, so like let's say you use immutable and stuff, that's going to replace the EC2 servers. It's never going to remove the RDS database, but if you, for whatever reason, delete that entire environment, your database is gone with it. Then on the other side, you have outside the Elastic Beanstalk environment. And the way you know you're doing this is you're creating your database first in RDS, and then you configure it with your EC2 instances that are inside your Elastic Beanstalk environment. Now, when the Elastic Beanstalk environment is terminated, the database is going to remain because it wasn't created part of the EB environment. And so these are generally suited for production environments. And with this setup, you generally are using blue-green deployment. You don't have to, but you totally can. And I just want you to know that distinction about inside and outside the environment. Hey, this is Andrew Brown from Exam Pro, and we made it to the end of the Elastic Beanstalk overview, and that means it's time for the cheat sheet. So let's review. Elastic Beanstalk handles the deployment from capacity provisioning, load balancing, auto-scaling to application health monitoring. So it really sets up a lot of infrastructure for you. It's a good time to use EB when you want to run a web app, but you don't want to have to think about the underlying infrastructure. And we just saw this big list of infrastructure above. It costs nothing to use EB, only the resources it provisions. So if it spins up RDS, an ELB, EC2, you're going to be paying for those, but EB itself costs nothing. Recommended for test or development apps, not recommended for production use. Remember, when AWS says this, when they say not for production use, they're talking about super large enterprises who think that they can use Elastic Beanstalk for their production environments. If you're a small to medium business, Elastic Beanstalk is A-OK. You can choose from the following pre-configured platforms. We have Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker. You can run containers on EB either in single container or multi-container mode. These containers are running on ECS instead of EC2. You can launch either a web environment or a worker environment. Web environments come in two types. We have single instance or load balance. For single instance environments, it launches a single EC2 instance, and it signs it an Elastic IP address to that EC2 instance. For a load balance environment, it's going to launch EC2 instances behind an ELB managed by an auto-scaling group. I didn't mention in the last one, but for the single instance environment, it is in an auto-scaling group as well. It's just set to set to desired capacity of 1. But I don't know that's important for the exam. It's not a big deal. Then you have your worker environments. This creates an SQL queue, installs the SQL daemon on all the EC2 instances, has an auto-scaling scaling policy, which will add or remove instances based on the queue size. Then we have EB has the following deployment policies. So we have all at once. So this takes all the servers out of service, applies changes, puts servers back in service. This is super fast and has downtime. So that is one condition you have to think about. Then you have rolling. It updates servers in batches, reduce capacity based on batch size. Rolling with additional batch adds new servers and batches to replace the old, never reduces capacity. Then you have immutable, creates the same amount of servers and switches all at once to the new servers, removing old servers. You really need to know these deployment policies inside and out, so make sure you know the difference. And if you don't know, go back to the lecture content, look at those diagrams, and make sure it clicks. And then we're on to the last page here. So rollback deployment policies require an ELB. So rollback, it should be called rolling. So I meant to write rolling. I'll update this here, but for the video, it's just going to say rollback. So rolling deployments. So rolling with additional batch policies requires an ELB, so it cannot be used with single instance web environments. Just consider that. In-place deployment is when deployment occurs within the environment. All deployment policies are in place. Blue-green is when deployment swaps environments, so outside an environment. When you have external resources such as RDS, which cannot be destroyed, it's suited for blue-green deployment. EB extensions is a folder which contains all configuration files. With EB, you can provide a custom image, which can improve provisioning times. If you let Elastic Beanstalk create the RDS instance, that means when you delete your environment, it will delete the database. This setup is intended for development and test environments. Really do consider that. And the last thing here is Docker AWS JSON is similar to ECS task definition file and defines multi-container configuration. So yeah, if you looked at task definition, you'll understand it. We don't have to go through the guts of that here, but this is generally what you need to know for the exam, but really know those deployment models, okay? Hey, this is Andrew Brown from Exam Pro, and we are going to start with the Elastic Beanstalk follow-along, where we're going to look at how to deploy Elastic Beanstalk a variety of different ways so we know it inside and out. I want to point out first, before we get started here, make sure you are in the correct region, and we always do everything in US East 1 because that's where the most abundance of AWS services are available, and it just makes things a lot easier. So just go up here and make sure you're in US East 1. And be very careful because AWS likes to switch out that region on you sometimes. So if you feel like things aren't going the way that it should be going, just double check your region. So now that we have that out of the way, let's go ahead and make our way over to Cloud9 because we're going to need a developer environment to run and test our application and then go ahead and take that over and deploy to Elastic Beanstalk. So I'm going to go ahead here to Cloud9. I don't have any region or environments created here, so we'll go ahead and create an environment. I'm going to name this dev env, which is developer environment here. It's saying not to use root account. I'm definitely not logged in as the root account, so I'm not sure why I'm getting that message. But we'll go ahead here, hit next. And what we're going to do is we're going to make sure this is a T2 micro. That's part of the free tier eligibility. We'll scroll down here and we have the choice between Amazon Linux and Ubuntu. Amazon Linux 1 is supposed to be unsupported at some point because they won't use Amazon Linux 2. So if you're watching this in the future, maybe Amazon Linux 2 will be here. You'll have to use Ubuntu. But if Amazon Linux 1 is here, absolutely use it because it is amazing. We're going to leave the default cost-saving settings here to 30 minutes. So if we don't have any activity or we don't have the browser open here, it will shut down the server, save us money. It looks like it wants to create an IAM role. We'll let it go ahead and do that. We'll go ahead and hit next. And down below, it has some best practices for us. And just shows us a confirmation of what we're creating. This is all great. So just hit create environment. And we'll just have to wait here a little bit and I'll see you here in a moment. All right, so our Cloud9 environment here is ready. And just before I get started, I like to use the dark theme. So I'm going to just switch it down here to the classic dark theme. And I also like to use Vim. I would recommend just using the default, but Vim is what I use. That rebinds all the keys for super efficiency. So, it's just because I've been doing it for years. But anyway, now that we have our Cloud9 environment, let's actually get an application going here. And since this is very developer focused, I think we should try to use the terminal as much as we can to get as much experience as possible. The first thing I want you to do is I want you to type in npm c9-g. So C9, which is short for Cloud9, this is a Node.js utility that makes it easy to open files directly from the terminal here. So we have this README file. And also just notice that, see where it says environment? This actually maps to this dev EVN directory. If I hover over there, you can see it'll autocomplete to that. So I don't know why Cloud9 does that, but that's how they name it. But anyway, I just want to show you how C9 works. So we have a README in here. And if I just wanted to open it up, it actually is, I think, open right there. But if I just typed in ls, and then I typed in C9 README, then it would open up that README file. So that is going to give us a little bit of help along the way. So now that we have C9 installed, let's go set up the actual application itself. And so the first thing we're going to do is we're going to type in mkdir, which makes a new directory. And we want to make that in our environment. So I'm going to use tilde to make sure I'm always at home. I'm going to type environment study sync is the name of the application we are creating today. And you can see up here that it created a folder. Okay. And we'll go ahead and we'll just create some additional files. So I'm just going to cd into that folder to save myself some trouble. And the first thing we need to do is initialize an empty node projects. We'll do npm init-y. Okay. And what that did is created a package.json for us here, which we will adjust momentarily. But we want to run a web app, so we're going to need some kind of web framework. So we're going to go ahead and use Express. Okay. So we'll go ahead and type that in. And what's that going to do? It's going to add it as a dependency there. So now we can use Express. The next thing we want to do is we're going to need some initial files to work with here. So I'm going to type in touch. We're going to type in main.js. We'll probably need index.html. Actually not, instead of main, we'll call it index. I think actually I normally call it index. Then we will have index.html, app.js, and style.css. And so that created all the initial files that we need to work with. And so now we just need to populate those files. So the first thing I want to do is I want to have a way of actually running our application here in Node. So we're going to add a new script up here called start. Okay, and we'll just type in node main.js. Actually, I'm going to call that index there. And the next thing we're going to do is we're going to start populating these files. So if you make your way over to the GitHub and you go to Exam Pro Co, the free AWS Developer Associate, there's a folder in here called study sync 000, and these are the files that we're going to copy on over. So the first is the index.js. So we'll go there and just hit raw, and we'll copy the contents here. And we'll double click on that, and we'll just paste it. Then we will click back here, and we'll go grab the styling. Okay, we'll hit raw. It's not that important for you to know how to program, but I mean, you know, we need to get as comfortable as we can here. So we're not going to really need to learn all this stuff that we're doing. Just copy, paste it through. And we just need, I think, the app.js file. Yep, the JavaScript file here. And we will grab all that data. And so those are the three files we need. And just give you a very quick tour of what's going on here. We have this index.html file. Oh, I guess we didn't populate that. Okay. Give me 2 seconds here. Sometimes you think you do something and you don't. So anyway, the index.html file loads this style.css file, which is located there. What we're doing is we're using a CDN to pull in Mithril, which is a JavaScript front-end framework. We are going to use app.js to load our JavaScript. Going over to our JavaScript here, we're using the Mithril framework. So it's very simple. We have this app here, and the idea is we're going to have a question, and we have multiple choices, and we can submit the answer somewhere. And then we just have some plain styling in CSS. So now that we have that all going, the next thing we need to do is actually preview this application, because before we can deploy it and package it, we need to make sure that it is working here. So I'm just going to go ahead here and close these tabs. And there's just going to be a couple things that we need to do next. Okay, so what we need to do is we need to get our application running to make sure that it's all in working order before we go ahead and package it. And so we can preview in Cloud9, but Cloud9 by default doesn't open up its ports to the internet. So we have to go ahead and do that. This would be no different than you setting up a web app on an EC2 instance. You'd still have to open up ports. And so generally the ports that Cloud9 allows out to the internet is 8080, 8081 and 8082. So what we'll do, I just want to show you how you normally do this. So you go here and you go to EC2 instances. You go to instances on the left-hand side, and we find the one that's running. That's our Cloud9 environment. And over here, we're going to find security groups. And if we expand that and we check inbound rules, we go here, edit, and we just add 8080, right? And then we restrict it to our IP. This is a development environment. Oops, I got to hit plus there. But we're not going to do it this way because I want you to get as much pragmatic experience because this is a developer associate. So we're going to figure out how to do it completely from the terminal. So we're going to do the exact same there. I know this is much faster, but like, trust me, this is going to help you in the long run for studying here. So let's get to it. So what we're going to do here, I'm just going to type clear here so my screen's nice and clean, is we need to figure out what the MAC address is for this EC2 instance. And then we're going to use that MAC address to get the security group IDs. And then from that, we'll use the CLI to update and create our own inbound rule. So whenever you want to get information about an EC2 instance, that is where the metadata service comes into play. And it's very easy to access on a server, whether you're here in your SSH into an EC2 instance or you're here in Cloud9. You just type in curl -s http:// and then it's 169.254.169.254 latest and metadata. So here it's showing you that there's a way you can get a lot of data in here. This 169.254, you should know this IP address. It should be etched into your brain because it's definitely a standard here when working with EC2. And as a developer, you need to know it. But we need to find the MAC address. And here we have this thing that says MAC. So we'll go ahead here and type in MAC. And now we have the MAC address. And the next thing is we're going to use this MAC address to find out all the security group IDs for the network interfaces that use that MAC. So what we'll do is we're going to hit up. And we're just going to back out here a bit, and we'll do network. And we'll just piecemeal it, because if you make the whole link, sometimes it's a big pain in the butt, and it's hard to hunt down the problems. So I'm going to just keep on doing this bit by bit. Oh, it just shows the MAC address there. That's even more convenient. And we'll just hit enter. And then we want our security group IDs. And there, so we only have one security group. If there was multiples, we'd like attach this EC2 instance, we'd probably see more, but we only have this single one here. So now that we have this security group ID, what we'll do is we will use the CLI. The CLI, AWS CLI is already installed on this Cloud9 environment because it's Amazon Linux 1, already comes pre-installed. And Cloud9 also loads your credentials from your user account, so we don't have to play with the credentials file here. If you're doing this on your local computer, you absolutely would have to set that up. We'll type in AWS EC2, and we'll type in authorize security groups ingress. And there is a new AWS CLI, and it has autocomplete. So like you could hit tab, and it would complete that stuff there for you. But I don't believe I have the latest one installed here, so I have to do things manually. And so we'll place in that security group. We'll say what port we want to open up. So port 8080. We'll have to specify the protocol. It's going to be a TCP. And then we need to supply the CIDR. So that's the IP address that we're going to want to be accessible. So before we hit enter here, we actually need to go get our IP address because that's what we're going to put in here. So what we'll do is use one of AWS's services, which is called Check IP. So it's a very useful service. Let's go use that now. So I just opened up a new tab here, and I'm just going to type in, check IP, Amazon, AWS.com, and this will tell me what my IP address for my local computer is. There's other websites like What's My IP, but let's use the AWS service because they took the time to make it for us. And we'll go back over here, and we will hit enter, and we want /32. That /32 is very, very important because that says only a single IP address. A CIDR block is a range of IP addresses. It's something we definitely cover in this course, and you definitely need to know what networking like CIDR blocks are in the associate. But for the time being, if you don't know what it is, just understand that you need to put your IP address in there and type in /. And what we'll do is we'll go hit enter. And actually, before we do that, no, we'll just hit enter. That's fine. So it didn't show us anything. So I believe that successfully created it. So we'll go over here and just take a look here to see if it actually made it. And there it is. But let's say that we didn't want to make our way over here and we wanted to do this pragmatically. Let's go confirm the security group through the CLI. So what we're going to do is type in AWS EC2 describe security groups. We're going to put in that group ID. It takes a bunch of them, but we only need one here. And we'll output it that says text. That allows us to, generally it's default JSON, but that's just really hard to read in this case. And then we're going to use filters. So we'll type in filters, name equals IP hyphen permission dot to hyphen port values equal 8080. So what I'm saying here is describe all the security groups to me and filter it out so we only select this security group, display this as text, and then filter it out so that we only see inbound rules that have port 8080. And we'll hit enter here. And we have a invalid command there. So I'm just going to double check here. I might have typed something wrong. Permissions does not look spelt correctly to me. Yeah, it's going to be PER, permissions. And I'm still having a bit of trouble here. IP hyphen permissions to port. Oh, you know what? It's a singular permissions. It's not with an S, I think. There we go. So it's a little bit hard to read, but the idea here is that it's going to say this is our security group that we returned. It's saying that port 8080 has been set, and that's the IP address. Now, if it hadn't been set and we ran this command, it would just show nothing. So the fact that something shows up here means that that inbound rule was created. But of course, in practicality, you'd probably just use the console. So now that we have, and we'll just type clear here to clear this stuff up. So now that we've opened that port, the next thing is actually getting the application running. But before we can even do that, we need to know what the actual IP address of this Cloud9 environment is. And I'm pretty sure if we use our EC2 instance here, we can go here and we can go and check it, and that is its public IP address. I think that would be the same thing, but let's again do it pragmatically. So we'll type in curl -s http ://169.254.169.254 latest metadata. I'm going to hit enter just so I'm not having too much trouble here. You can even see right here, it's public IPv4. So we'll type in public IPv4. And it says 385.910. I'm going to go back here. Yep, so it's the same one there. So that's what we're going to use to access the web application. And let's go ahead and actually start this application up. So to start it up, we just have to make sure we're in that study sync directory here. And we want to start it up on port 8080. So if you're wondering, like, why are we typing port 8080 there? The way this application works, if you open up the index.js, it uses process env port, and it's going to pass that port number to Express. So it knows to start up on that port number. And so what we'll do here is we'll just go and type in npm start. And we'll see if this starts up. And we have a little error here, and that's totally okay. It says failed to parse package.json data. You know what happened? We forgot a comma. This is something I do all the time. So remember we wrote this line in here. We have to just make sure there's a comma on the end of it or it's not valid JSON. And I'm just going to go back down here, hit Control-C, which kills that there. And we'll hit up again. We'll see if we're in better shape. So now it says that it's launched on port 8080. So what we can do now is get that IP address that we have earlier. So it is somewhere in here. Can't seem to see it. So I'm just going to go here and copy this here and make a new tab in terminal and just paste it in. Of course, we could just go to EC2 instance, but Why do that when we can try to do it the proper way? And so what we'll need to do is do this and say port 8080. We're not going to open it up here, but I'm just typing it out so that I'm having less trouble here. And we'll just copy that, and we will see if this works. And there's our application. So this application doesn't really do much. You can select something and submit, but it doesn't really submit to anywhere. Maybe we will start hooking this up and do more with it. I call this the Study Sync application. It's supposed to help you study, I guess. But it's just a superficial application. So now that we have our application running and we can preview it from Cloud9 and we have some CLI experience, the next thing is to get a Git repository set up. So that's what we'll do next. Okay, so let's get Git going here, and I'm just going to go ahead and close this bash command. We'll go back here, and we'll just stop the server. I'm doing that by typing Control-C on my keyboard. You can see that it says Control-C. This little icon represents control. And we're going to need a .gitignore file because there's files that we just do not want to include. So up here, when we have node modules, this is how Node works. They just put all the libraries in line, and we do not want that in our Git repo. That's just too much stuff. And so with Git, there's a file called .gitignore. And what we'll do is we'll just make sure we create it here in our study sync directory. So just make sure you're in environment study sync. If you're not sure where you are, just type in environment study sync as such. And then we will just go ahead and touch a .gitignore file. And that should now exist. I just don't see it here on the left-hand side. It might be hiding it, or we might have to hit refresh. Well, I definitely know that it's there. So, because if we do an ls-la, there we can see that hidden file. There's probably a way to turn it on there. I'm just not sure at the current moment. But that's fine because this is all about learning how to use the terminal and CLI as a developer. So if we want to open up that .gitignore, we're going to use our handy dandy C9 command, .gitignore. And if you don't want to type everything, you just hit tab on your keyboard. That saves a lot of time when you're auto-completing stuff. Works for most things. And what we're going to do is type in node modules. What that's going to do, it's going to ignore this file completely, this folder completely, because we don't need to include that with Git. Now that we have that set up, you may want to set up your Git config global username and email. We're not going to worry about it right now, but we'll probably be prompted for it, and it'll just be an annoying message every time we see it. So now that we have our git ignore, let's set up our Git, let's actually set up this Git repo. So we'll type in git init, and it's initialized an empty repo. It's created a new folder called .git here. So if I just do an ls-la, you can see I have a .git directory now. And we're not going to really get into the details about Git here, but just showing you what's going on. The next thing we want to do is we want to add all the stuff that we've worked on so far to our actual repo. So if we type in git status, it'll show that we have these untracked files, meaning that they aren't going to be committed. So let's add them to be committed. So we have to do git add. We'll do git add period. That will just add them all. So we'll hit enter. We'll type in git status. And so now you see it went from untracked to changes to be committed. And so now we just need to write our git commit message -m initial commit. And they are now committed. And there's that thing I was talking about, that git config username and email. Generally, you want to set these with your name and email. Since I'm just doing this for practice here, I'm not going to do that. And it'll probably keep on popping up. But we've created a Git repository, but it only lives on this Cloud9 environment. And we really want to make sure that this is hosted somewhere in the cloud. You could use GitHub. But for this course, this project, we are going to be using CodeCommit so that we get some hands-on experience with that. I think a lot of developers already have a lot of experience with GitHub. Yeah, we'll get to that next here. So I said the next thing we want to do is get this this local repo. That's this folder here. Well, we can't see it on the left-hand side because it's hidden. But we want to get this all the contents of this entire folder and this .git file into a repo, and we're going to use CodeCommit. Now, when you use the Elastic Beanstalk CLI, you're setting up a project for the new time. The first time it will set up a CodeCommit project for you, and so I figured that's the way we should go ahead and do it. So we'll just go up here and make a new tab. Because the CLI is not pre-installed, so the AWS CLI is pre-installed on this Cloud9 instance, but not the Elastic Beanstalk one. So what we'll do here is we're just going to go ahead and type in Elastic Beanstalk CLI, GitHub, and because that's going to have the instructions for us to do this install here. And so I'm just going to scroll down here, and based on your environment, you might have to install additional things. You can see there's a bunch of things. But since we were working with Cloud9, there's not going to be anything that's too difficult here. And all we have to do to install this is to run the git clone command. So let's go ahead and give that a go. So we'll make our way back to our Cloud9 environment. I'm just going to type in clear so we can see what we're doing. And I'm just going to go back one directory because this is going to clone that repo, like download this folder. And I just don't want it having in my study sync here. So I'm just going to go back a directory, which is just cd ... And we're going to type in git clone. And this is already complaining. Too many arguments. Oh, you know what? Because when we copied it, it already typed git clone for us. It was trying to save me some trouble. So I'm going to go back and copy it. I wrote it in manually. I'm silly. And we'll hit enter, and that's going to clone it. So that's just going to download it to our local computer. And now to run it, if we go over here, it should be probably this command. Yep, that's the command. So we'll go back here and we'll just hit enter. And what it's going to do is it's going to install a bunch of stuff. This is probably not, this Cloud9 environment is probably not using this version of Python. If we just go over here, new tab, we're not gonna mess with this one. But if I just type in, I think it's like, if we just type in Python -version here. Oops, I didn't want that. Hyphen version maybe. Okay, so it says version 3.610, and this one wants version 3.72. So, you know, that's just the state of Amazon Linux 1 right now. And we're just going to have to wait. This is going to take a few minutes, as it says here. I'm just going to go over here. Every time I stop the video, I have to hit a command key and it messes up terminal. But we're just going to wait for this to install. And this, again, takes several minutes. So please be patient. You know, it might be 3-4 minutes. And I'll see you back here in a moment. Okay, so just waiting here a little bit here, coming back to our first tab, we can see that it has completed. So it just took a little bit of time to install Python. And there's one more thing that we need to do, and it's just to add this Elastic Beanstalk to our path. So if we were to type in EP, it shouldn't be able to find it because it just doesn't know where that binary is stored. So we just need to take its recommendation here. We are using bash. You can tell we're using bash. This is bash up here. And we just need to echo that command here. And I'll just hit that. It also seems to suggest this. I don't remember having to do this last time, and I think we can go ahead and do that. I think it's safe to do so. I hope that doesn't mess up this follow along here, but I'm pretty sure that won't. And so now if we type in EB, we have Elastic Beanstalk pop up. So that's really great. What I want you to do is just delete this folder. We don't need it anymore. It's just creating clutter. So just type in ls-la. Make sure you are at this environment directory. If you don't know, just type in cd:/environment, and we'll type in rm-rf, AWS autocomplete it, hit enter, and we saw that it vanished there. So it's just a bit of house cleaning because we don't need that sticking around. So now that we have the Elastic Beanstalk environment installed, or the CLI, let's see what we can do with it, which it will be actually setting up an application. I'm just going to close this other tab here, and I'll see you here in a moment. So now that we have the CLI installed, we're ready to initialize a new Elastic Beanstalk project. Now I want to point out that we are currently in tilde environment. That's our home directory. It's very important that we run this command in the study sync directory because it needs to find this .git directory in order for it to upload our code to code commit. So just type in cd /environment study sync and do ls-la. Make sure you see that .git directory there. Before we get going here, I'm just going to open up a couple tabs in AWS. And we're going to go to one that's actually at the CLI here. So we're going to make our way, to Elastic Beanstalk. And then for this one, we're going to make sure that it's on code commit. just so we can see what's happening in the background here. So what I want you to do is I want you to type in EB. We'll give you a full list of commands. We'll probably won't end up using all these commands, but these are the most general ones. And they tell you to use ebinit, ebcreate, and then ebopen. For ebopen, we don't actually have the ability to use this command. This makes it so the application opens up in the URL in the browser, which is very convenient. If you're running Elastic Beanstalk on your local computer, not in Cloud9, that's a great command to use, but here we won't be able to use it. But let's go ahead and do ebinit. The first thing it's going to ask us is the region. We definitely want to default that to US East 1, always US East 1 because it makes things easier. It's going to ask us to select an application. It's going to be study sync. It knows that because it's picking it up from the .git folder there. It's going to ask us if we're using Node.js. We absolutely are, so yes. Do we want to use code commit? We'll say yes. And then enter the repository name. We're going to call this study sync. And then it's going to ask us if, or what we want our default branch to be. We want it to be master. We'll just type in master. We can just hit enter there either. And what it's going to do, it's going to go ahead here and in code commit, it will show us that it created that repo. So here it is. So it's now here in code commit. In Elastic Beanstalk, we're not going to see anything here yet. This is just an old one here, but if I do a refresh, I go back here. Well, you probably won't see this, but I had older terminated instances here, so you might not see anything here as of yet. And then down below, it's going to ask us if we want to set up SSH access. I'm going to say no, we do not need that. And so now we've initialized our project. Notice that it's created a new folder called eb elastic.beanstalk. The period means that it's a hidden folder. We're going to go and open up this config.yaml file. And so these are some of the options we chose when setting up the ebinit. So now that we've initialized our project, and we have our code on code commit, we need to configure this application. So we'll move on to, or the Elastic Beanstalk environment. So we'll move on to that next. Okay, so the next thing we need to do is configure this environment. So you generally have to do this for all Elastic Beanstalk projects based on what environment you're using. And configurations show up in the .eb extensions directory, so we'll have to create one ourselves. So I'm just going to type clear here. I'm going to make sure that I'm in the right place, so study sync. And I'm just going to type in mkdir, which is going to make a new folder, .eb extensions. Okay, and so now I have that new folder there. I'm just going to double check it, EB extensions, that is totally correct. And we're going to need to create a couple files in here. So I'm going to do touch, I'm just going to cd into this EB extensions folder. They'll save me some time. I'm going to touch a file called 001envar.config. And I'm going to do another one called node command. And then I'm just going to go back a directory. So if we open up this folder here, we now have envar, and this is where we're going to set some default environment variables. By default, you don't have to specify an environment here. It would just go to the Elastic Beanstalk environment, but we are going to be explicit here. And this is what we want to type. I always type the word environment wrong. environment. We need a colon on the end there. And so I'm just going to set port 8081, and we're going to say node env production. And it's 4 spaces indent. That's totally fine. I'm just going to leave it alone. And so that is one file configured. Then we will go over to the next one here. I'm just going to double check this one here. Option settings. Yep, that's all good. And so the next thing we need to do is tell Elastic Beanstalk actually how to start up our application, because it has no idea. So we'll do AWS, Elastic Beanstalk, container, and then Node.js. So we're going to give it some Node.js specific configurations here. First, we're going to provide node command. That's going to tell what command it's going to run when it first starts up. We want it to npm start. And then we need to specify the node version. This is going to be 10.18.1. I actually don't have to put the parentheses there. use double quotes. I think you use single quotes, but I'm just going to stick to what I wrote earlier because I don't want anything to go wrong in my follow along here. And if you do node-version, you can see that it's using 10.19.0, and it is better to use the latest version, but that doesn't necessarily mean that those like Elastic Beanstalk can run that. I definitely know that 10.19 is not out for Elastic Beanstalk, and 10.18.1 is available, so we'll stick with this one. But yeah, that's the configuration there. So we'll go ahead and we'll just commit it. So git add all, git commit -m, configuration for Elastic Beanstalk. It's very important that we do commit this and then we push it, because if these files aren't there and we try to create an environment, it's just going to error out because it always looks at what's in the repo here. So if I go into here, code commit, EB extensions, we can see we have those files there. So that is the configuration phase over here. I'm just going to close a couple of things here, just clean up here a bit. And what we'll do next is we'll actually create a new Elastic Beanstalk environment. All right, so we are ready to create our Elastic Beanstalk environment. And to do that, we need to use the EB create command. But we're not just going to write EB create, we're going to write EB create --single. This --single, this is a command flag. What it's going to do is tell this to create a environment, an EB environment that is running in single instance mode. If you don't provide this flag, it's going to spin up an Elastic Load Balancer. Elastic Load Balancers cost money. Technically, if you're using the free tier, if you made this account and you're still in your first year, you get 1 ELB free running. But you know, we just want to avoid these kind of problems, so let's just not use it. And we're not going to really be doing anything with Elastic Load Balancer anyway through this walkthrough. So do EB single. It's going to prompt us with some options. I'm going to name this study sync prod, even though we're in our environment or developer environment for my AWS account. If you go back up here, mine says exampro dev. I'm going to pretend this is a production application. And I'm going to hit enter there. We just want that to be the same. We don't want to use spot instances, but that's a great way to save money. And then it says it's insufficient IAM privileges, unable to determine if this rule exists, assuming that it exists. And it's going to go ahead and spin that up. I don't know if this is going to cause us a problem, but we're going to have to wait here. And this is just going to take a little bit of time to get going here. So I'm just going to wait for this to get started. I'm going to open up another terminal here. And I'm just going to go to study sync here. And I'm just going to type in EB status. And this actually shows us the current status of the application. Right now, the health is gray and the status is launching. If we go over here, you can see I was trying to launch some stuff earlier here. Those are terminated instances. This is the new one here, pending. And you can see it's a nice dark gray. And this mirrors exactly what we're looking at over here. So this is going to take about 5 to 10 minutes to launch. And I will see you back here momentarily. Okay, so after waiting a little while here, I go back here and it says that it successfully launched the EC2 instance. So it looks like to me that it's all in good working order. We go over here and we type in EB status. You can see that it says ready and yellow. Yellow is not a great status to have. So if we come back over to the Elastic Beanstalk environment, I can't tell if it's finished yet, but I'm just going to go back here to study sync, click into the yellow here. And it's giving us a warning. It's saying, unable to assume the role, AWS Elastic Beanstalk service role. So it's supposed to create that for us, but for whatever reason, it just did not. When I first wrote this follow along, it definitely created that for me. So I'm not sure why it's not creating it, but if we go up to this link here and open it up here, the application clearly is working. So yeah, the yellow command's not that great, but maybe it'll go away on its own. I'm just gonna hit refresh. So I'm just going to wait a little bit here and see if it actually does go away or not. Okay, so our yellow eventually became a red, and it really has to do with this AWS Elastic Beanstalk service role. This is confusing because when you run EB create, it's supposed to create this for you. It's supposed to actually create 2 different IAM roles. If I go over here, I don't see them in here at all. Now, you could go ahead and manually create them. I've tried to do this and I haven't had much success as well, but there is another way for us to create these roles without us having to do a lot of manual labor. And again, you might not have to do this. Those EC2 roles or IAM roles may exist, but in my case, I'm just having a hard time today with Elastic Beanstalk. So to get them created, what I'm going to do is I'm just going to start another Elastic Beanstalk project. So I'll go here, create a new app. I'll just call it test, it doesn't matter. Because if we launch one from here, it will absolutely create us those roles. So I'm just going to go here, go to web server environment. I'm going to leave it as test. I'm going to choose Ruby. I'm going to go down here and launch a sample application that will launch Rails. I'm just going to write test in here. Check for availability. That's all good. Hit create environment. And so what that should do is it should trigger through the console that should go create those IAM roles. So if I refresh here, now you see they exist. AWS Elastic Beanstalk EC2 role, AWS Elastic Beanstalk service role. So I have no idea why those aren't appearing, but now they do. But the trick is I just need to delete this environment now. So I can't stop this as it's running. So we'll have to wait till it goes through the motions of it for this test environment. And then once it's done here, we'll just go ahead and terminate it. Okay, so the environment spun up, and now we just have to go ahead and delete it. I know this is really silly, but I mean, that's the only way I can get these roles to be created. But you know, they definitely should be able to make them manually, and this definitely should automatically happen. But I'm going to go back. I just clicked to all applications here. Then we'll go into here on the right-hand side. We'll see if we can go ahead and delete it here. So I'll just put test in here. And so what that will do is it should automatically start deleting this environment. So if I go into here, it's terminating it. So that's that. But this environment is just no good. So what we'll do is, I mean, we can terminate it, I suppose. I guess what we'll do is we'll just terminate this environment as well. So I'm just going to go here and type this in here. And I'm just going to wait for this one to delete. And then we'll try EB create again. And hopefully we won't have any issues this time around. Okay, so I did a refresh there and it's terminated. And what I'm going to do is I'm going to go back to Cloud9. And I'm going to try this again. So I'm going to go back to our first tab here. I'm going to just hit up. It's going to ask me for the name. So I'm going to do study sync prod, hit enter again. We don't want spot here. And it's saying that AWS Elastic Beanstalk EC2 role, it can't find it. That's okay. When I first did this, I had that error and it wasn't an issue. But let's just really make sure that it actually is there. Because as long as it's there, that's all that matters. Okay, so the role is there. So we shouldn't have any problems this time around. But we'll just wait here and see what the result is. I'm just going to go over to Elastic Beanstalk, give it a refresh, click in it here, and we'll just wait a few minutes and see how it goes. Okay, great. So this Elastic Beanstalk has gone green. So us creating that temporary application, even though as silly as it is, fixed the issue here. Hopefully you don't have to do that and those roles just exist for you. So if we go over to Cloud9 here, I'm just going to do a clear here. If you do EB status, that's going to show you the status here. So green and ready, which is the same thing that is over here. If we wanted to go view this web application, it shows the CNAME in here. So if I copy this out, we can see we have a link there. If we scroll up here, we can also see that it assigned us an Elastic IP address. So that's another way of accessing the web application here, is that IP address. If we typed in EB logs, this would show us what happened actually on the EC2 instance, if anything was logged out. I might have showed you this prior, but I'm going to just show you quickly here again. And so you can see that the application started up here. I'm not sure what's going on down below here. I don't think that matters, but this is what we really do want to see. We'll hit Q to exit that out there. If we type in EB events, that is going to show us the event history that has happened. So if you go over here in events, that's the same information here. Really great way to debug stuff. And I want to point out that the deployment model we're using is all at once right now. We haven't actually done a deploy yet. We technically have deployed, but we haven't deployed to an existing environment. So I'm just showing you that it's using all at once. And so the next thing we're going to do is switch this over to immutable and see what the difference is there. But we're not going to do it in here. We could just click immutable, hit apply, and then do a deploy. But I want to do everything through the console. So that's what we're going to do next here. So let's get to that. So to switch this over to immutable deploys, again, I said that we could modify this file, but we want to do it pragmatically, and we're going to do that through the configuration files. So what I want you to do is go into eb.extensions here. Oh, it's not letting me type. If that happens to you, you can just close bash and open a new window here. I already have one open. And I'm just going to go into eb extensions. I'm going to make a new file, and I'm going to call this 000 deploy.config. I just want it to be ahead of those other ones. I don't think that order really matters, but it's just what I want to do. Oops, it's not make. We want to do touch. So we'll touch a new file there. And what we're going to do here is we're going to set option settings. And we're going to do AWS Elastic Beanstalk here. And we're going to do command. And what we're going to do is set the deployment policy to be immutable. And then what we're also going to do is set health check success threshold to warning. And then we're going to set ignore health check to true. And we're going to set timeout to 600 here. So I'm just going to read this over very quickly here. Make sure I didn't make any mistakes here. Elastic Beanstalk, that's correct. Immutable or deployment policies, immutable, that looks right to me. Health check status threshold, that looks good to me. Ignore health check. So we're going to say over here what we're doing, we're actually checkboxing that off, okay? And we're pretty much setting the same settings that are here, except this is going to be warning. And that should make the deploy really fast. And also, while we're at it, let's just make a superficial change. So when we do deploy, we can actually see if the effects have taken effect here. So I'm just going to go to our actual application here. I'm going to just change this to Study Sync. Version 1. If we were to actually check out this application before we deploy it here, notice that this says Hello World here. So we're changing that to Study Sync version 1. We're going to go back to bash here. We're going to go back a directory. Just going to type clear. Make sure you're in the environment's Study Sync in here. And we're going to add all the changes. So we modified that file. We added a new configuration file. So I'm going to add them both. Git commit -m immutable deploys. I'm going to push those changes. I'm going to go ahead and deploy that. So we'll just type in eb deploy. And right away, it should start switching over to immutable deploys, because it's going to pull those configuration files, look at them, and then it's going to decide on what to do. So if I think we just wait here a moment, it's actually going to tell us. And we can see that I actually have an error here. So I'm going to go ahead and abort that. So I can just type eb abort. But we can see it contains invalid key option settings. So I probably just made a mistake here. Oops. Yep. We'll try this again, eb deploy. Oh, well, we have to commit those changes. Git push. We'll do eb deploy again. And so what we're looking for is to see if it'll actually say that it's doing an immutable deploy. And there it is. It says immutable deployment policy enabled. So we're going to have to wait for that deploy to happen. I'm just going to open a new tab here because I'm going to stop the video here. And immutable deploys are a lot slower than all at once, but the advantage here is that it won't take our server out of service. It's going to create a new server, and then when that new server is good, it's going to switch over to it. So our users will never have an interruption in service. So I'll see you back here shortly. All right, great. So our immutable deploy has completed. It's actually been quite a while since last time I was here because I'm actually recording this the next day. But I can tell you that that immutable deploy didn't take too long. So it definitely takes longer than the all-at-once deploy. All-at-once is extremely fast, where these immutable deploys have to go through health checks and then go through multiple checks before it determines that the new service is good and moves over. So, that was immutable deploy, but what I want you to do is go back to Cloud 9, and we are just going to undo those changes there, because the next thing we're going to learn how to do is blue-green deployment, and I don't want these immutable deploys slowing down our development here. So just to get rid of this immutable deploy stuff, all we're going to do is remove that file there. So I want you to type in rm, and we're going to do tilde here, environments, study sync, EB extensions, 000 config deploy, and then we're just going to add those changes. I'm going to make sure that I'm in that study sync directory there, because it looks like I was in the wrong place there. And we will do git add all, git commit -m, revert back to immutable deploys. Okay, git push. And just before we do anything else here, I just want to go back to the environment here and just show you under your configuration that it should have switched to immutable deploys. So here you can see it's immutable and the health checks are disabled. But anyway, now that we have that set up, all I'm going to do here is, now that I've made these changes, I did a push. I'm just going to do a cap deploy, or so not cap deploy, EB deploy. I'm thinking of Capistrano, which is for Ruby on Rails. It's not what we're doing here. And what we'll do is we'll just revert this back to all at once. And this isn't going to take too long. So I'm just going to go back here to my dashboard, and we can see this is updating. And I'll see you here when this is done, and then we'll move on to blue-green deployments, which should be super exciting. All right, so after a short wait there, our mutable deploys are back to all-at-once deploys, and we can just double check here under the configuration. If we go down here, we should see now it's all at once. So let's move on to blue-green deploy. So blue-green deploy is when you switch environments. So right now we have this environment here, which we can consider our blue environment. And the idea is we're going to spin up an identical environment called our green environment, which will have our latest changes. And once that environment is in good shape, what we'll do is we will swap the URL of the environments. Now, this option isn't available to us right now because there's nothing for it to swap to, but once we have that other environment, that's how we will make that switch over. So in order to do so, we're gonna go back to Cloud 9, and what we need to do is clone this environment, make a copy of it. And we could go in here, and I think we could go right into here and then click actions and clone the environment. But let's do it through the CLI, because again, this is the developer associate. This is the best way to learn. So we're going to type in EB clone, and then it's going to prompt us for the name. I think clone is okay for our case here, so I'll hit enter. We'll keep the CNAME the same. And what it's going to do is start up a new environment there. So we'll go back to study sync, and I'm just going to give it a refresh. And here we can see that this environment is spinning up. So again, we're going to have to wait a little bit here, and I will see you back momentarily. All right, so after a short wait there, because it's using all-at-once deployment, we have our production clone environment up. I know it doesn't look like it's running here, but if we just go back here a second, and I do a refresh here, we can see now it's green. So don't always trust the AWS console. Always refresh and look around, because sometimes things are ready and you're just waiting around for nothing. So if we take a look here at this clone environment following this this CNAME here, or the DNS, what do they call it? We'll just say URL. This URL here, we can see that it's running, but we want to make sure that we have a new version here. So this is version 1. So let's just make a superficial change calling it version 2 and then see how we can deploy to this new environment and then facilitate the switch. So what I'm going to do is go back to Cloud9 and I'm going to make my way over to the app, and it's just making some complaints here. So I'm going to close these tabs. And what we want to do is we want to go ahead and open this app.js file. And I'm going to just change this to version 2. All right. And so now that I've changed it to version 2, I'm going to commit this to the repo. So I'm going to go git add. Well, I'll do git status. We should always do that. We can see the file we want to add. Git add all. Git commit. Change to version 2. We will do a git push. Git status. All right, great. So our version 2 is there. So how would we go about deploying to the green environment? Because we have these two environments. So if we ran EB deploy, I think by default it's going to deploy to the original environment. But if we want to specify the environment we want to deploy to, which is the green environment, we just have to provide its name. So that's called study sync prod clone. I'm pretty sure that's the name of it. Yep, study sync prod clone. And so this should now deploy the latest changes to this environment. So we'll go ahead and press that there. And it's going to start up again. We'll just give it a second here. We'll flip back. We will go back to study sync. I'm just going to give it a refresh here because something should be changing. Probably the prod. Yep, so it's updating. So we will let that deploy there. We'll give that a little bit of time. And I will see you back here when that's done. And we'll just double check it's version 2. And if that's all good, we can do the swap. All right, so pushing our changes, our version 2 changes to the clone is done. If we go to this page and refresh, you're going to notice that there hasn't been any change, but it actually has worked. This is just an issue with Chrome, because if you open up another browser and refresh in Firefox, it says version 2 for the same URL. So this is a Chrome caching issue. I spent hours upon hours trying to solve this problem and not realizing it's Chrome. So just be aware that anytime you're doing deployments to anything and you're checking stuff, always just rule out your browser, because sometimes it's not even AWS. So, you know, if we want to get to see the latest version here, I'm going to open up Inspector, make sure you're on network and have disabled cache, do a refresh there, and now it says version 2. This will not work unless you have this open, this checkbox, and then you do the refresh. All right. But yeah, now that we have figured out how to deploy our second version with blue-green deployment, what we can go ahead and do is swap over the environment URL. And so we said that what we could do is go to here to Actions and go to Swap Environment URL. And we could go here and choose our other version and swap here. However, since this is for the Developer Associate, I really do want you to get as much experience with the CLI. I'm going to just keep on saying that. And what we're going to do is go ahead and use Cloud9 and use the actual EB CLI to do that. So the command here is EB swap, and then we're going to say if we hit enter now, it would prompt us to ask, you know, the source and the destination. But I just want to be very explicit here, and I'm going to just type in the source. So I want to swap the prod with the clone. So we'll say study sync prod clone. And this will do exactly the same thing as swapping the URL out here, okay? And I'm just going to hit enter. Unrecognized argument here, clone. Let me just make sure that I spelt that name correctly. I'm just going to go over here and check. Study sync prod clone. Study sync prod clone. Oh, sorry. You know what? I have to provide a flag here. It is hyphen destination name. And now we'll hit enter. And this is going to trigger that swap action there. And so we're just going to have to wait a little bit there. And it says it's completed the swap. Wow, that was really fast. So we'll go back here. And if we are to click on prod now, what I want you to notice is this is the clone URL here, right? And we are now in the clone environment. So this used to say clone, but now it says prod. It's taking the original CNAME from the other environment. If we go to The first environment here, this one now has clone. So that's the swap that occurred. So that's how we know that it worked. Now that that swap has occurred, what we want to do is just get rid of our old environment because we know our new environment is running with no problems here. If we just go to prod like this, it's running version 2, so we're all good. And so what we need to do is go in here and then just terminate this environment. But let's do it from the CLI. So we'll go back here to Cloud9. And what we're going to do is type in EB, terminate, study, sync, prod. And then it's going to just ask us to confirm it. We'll hit enter. And that's going to terminate. Now, we're pretty much done with blue-green deployment here. And with that out of the way, we can actually move on to learning how to deploy a single Docker container next. So what we're going to need to do is rip down everything because we do not need even this clone anymore. So I'm going to also terminate this one, but I'm going to do it through the console here. And we need to type its environment name. So I'm just going to copy it here. Paste that in. Make sure that's right. And what we're going to do is we're going to wait for these to shut down here. And when these are both terminated, we'll move on to the next step, which is deploying a single container Docker environment to Elastic Beanstalk. All right, so we are back here. It went through the whole process here and built everything, and it's saying that it's running on port 8080. What we're going to need to do is open a new tab here because we're going to need to get the IP address of this Docker or this Cloud9 environment. So we go to a terminal here. I'm going to type in curl http://169.254.169.254 latest metadata. We'll hit enter, make sure this works. And then we'll type /public IPv4. And that's the IP address. So what we can do with this is just copy this here and go port 8080, and we will see if this works. Oh, let's just click it too, eh? Open. And there it is. So this is running in a single Docker container. The reason you'd want to Dockerize your environment is because it allows you to ship your configuration with your code base. So you saw before we were restricted to version 10.18 whatever of Node, but now we are only restricted to whatever we provide with it. So a lot more flexibility around that. In order to prepare this for deployment, we aren't going to need this node modules anymore because we are using a Docker container, and this is just going to do nothing. So we'll go ahead and remove that. So what I want you to do is just close this tab here. I'm going to do Control-C to stop the Docker container. I'm going to go CD tilde. Oh, we're already in the right place, but this is where we need to be. And we're just going to do RM, EB extension, 002, and just remove that file. So now that's been removed, we need to make an adjustment to this file here. I'll just hit keep open. This needs to be port 8080 because that's what we're setting in our application. And let's go ahead and commit our changes here. So configure EB for Docker. And so now that our pushes have been changed, what we can do is go ahead and do an EB create -- single so we don't launch a load balancer. We are going to name this one different just so we can identify it. So we're going to say study sync Docker. We'll hit enter. We'll hit no, we don't want spot instances. And we will make our way over to the Cloud9 over here, do a refresh. We'll give it a second here to start up. There it goes. We can see that it's using the Docker platform. We'll do a refresh, and we will just wait until this is done and see if it works. So after a little while there, our environment is now running here. Let's take a look to see if it's working. And there you go. We're running on Docker. It was that easy. The thing with Elastic Beanstalk is that it did all the work for us. We just had the Docker file in here, and when we uploaded it, it did all the work. It built the image for us. But normally what you'd have to do is build the image yourself and then push it to an actual Docker repository. That could be Docker Hub, or in the case of AWS, you can use Elastic Container Registry, ECR. And that's what we're going to do, because that's a more complex setup and the more common setup that people will be using, because most people outgrow this Docker file, this simple setup here. In order to do that, what we're going to need to do is create a new file called a docker run aws.json file, and we're going to have to build an image and push it to ECR. But before we do that, let's just make a revision to our actual code base here. And we will go to app.js, and we'll call this version 3. And the next thing we will do is we'll go ahead and build our Docker image. So I'm going to type in docker build -t study sync period. So this is going to build a Docker image. And it's going to name it study sync. So we'll just wait here a little bit, and there it is. It's done. That was fast. The next thing we need to do is we need to authenticate to ECR. And this is a very long command, so we'll get to it. It's AWS ECR get login password pipe docker login -- username AWS -- password STIN. We're going to have to provide our account ID here. I don't know what my account ID is for this account. We need to poke around. We should be able to find it somewhere. It's generally under my account settings. I just don't want to show all of my billing information here. So another easier way, we'll just go make our way over to IAM. I feel like that's always a place where we see our account number. We should see it anywhere. We'll just go into even a user here. Here's one. Our account number is everywhere. I just need part of it there, so I'm just going to paste it over here and then extract it out. And then what we need to do is provide it as such. And then we need to type in this URL. So we need dkr.ecr. And then we need the region we're operating in, so US East 1 dot Amazon AWS.com. If you're wondering how I got this whole link, it's in the AWS documentations for ECR. So what this is going to do is log us in and generate us out a token so we can authenticate. So it says there's an unknown flag named user, so I'm just going to double check that there. It's actually supposed to be username. So we'll go ahead here and type this in. And here it says that it's created that credentials helper file. So there you go. So notice that it's created a file here called a hidden file called docker config.json, and that's what's storing the token, which is going to help us to authenticate. So let's take a look at the actual images that are here. And we can see that we have our image that is built here, and we're going to have to get this image ID next. And what we need to do is tag this Docker image. So I'm going to put in that image ID. We need our account ID again here. And it's actually the same link here, so it'd probably be easier if I just copy that out like that. And then we need to specify the name. And so now that it has been tagged, what we can do is do docker push. And I believe it is the same URL here, so we'll just copy this. And it says here that the repository does not exist with this ID. So maybe what we should do is make our way over to ECR, and just maybe we need to make the repo beforehand. I always forget this, so I guess we'll find out. I thought it would just create it for us. Nope, I guess not. So we'll just type in study sync here. I'll hit create repository. Then we'll make our way back to Cloud9, just hit up. And there we go. It's uploading our Docker image. It's kind of like GitHub. This is an incredibly small Docker image, so it's not taking too long, which is really nice. One advantage of using Node.js over other languages and frameworks. So I'll just wait here a little bit and I'll see you back in a moment. So our Docker image is now built and pushed to our ECR repo here. So if we go in here, we can see that we have it. And the next thing is to prepare our actual, this next environment here. And instead of working with this one, because it's going to be a lot of work here, we're just going to make a new folder. So once you go cd dot, or just go actually here to cd tilde/environment, we're going to make a new directory, and we're going to call it study sync external. And what I want you to do is make a new file in here. So we'll just cd into this, and we're going to call it docker run.aws.json. If you've ever seen a task definition file, it's extremely similar. And in this Developer Associate course, we definitely cover how to deploy with ECS and Fargate. So this will become extremely familiar to you shortly. But what we need to do is open up that file. I made it as a directory. That was an accident. I should have made that a file. So I'm just going to remove that. And instead of doing mkdir, I'm going to type in touch. Okay, and then we can just open up that file there. And what we're going to do is write some JSON. So the first thing we need to do is define the Docker version for EBS here. So Docker run version. Just going to double check, make sure that is correct. Yep, that is right. And we're going to specify version 1. Version 1 is for single containers. When you're doing multi-container, you do version 2. Then we need to specify the image. And that's going to be the URL we were seeing there earlier. I feel like we could grab that from ECR. Yep, it's pretty much the same thing here. I just want this part of it. I don't know if I need to put latest in there. So we'll put that in there. We have to specify the ports. So we'll go ahead here and do that. So it knows what to map to. And in that, we will do this. A little bit of cleanup here. I'm just going to double check to make sure everything is right here. Sometimes it's easy to miss these commas. It looks all correct to me, so we're in good shape. The next thing we need to do is initialize a Git repo here. So we're going to do git init. And we're going to copy over a couple files. So we want to bring over our gitignore EB extensions file and our envar.config file, I think. So we will go ahead and do that. I'm just trying to think of the easiest way to do this. Probably just make the files again. So I'm going to just type touch.gitignore. And then we will do, we'll make a new directory called EB extensions. And then we will touch EB extensions 001.envar config. And I think that's the only two files we need to move over. So we will go to our old one here. And it has some Elastic Beanstalk stuff in here, and then we'll just take all of it. That's totally fine. And we'll go to our new one here and paste that in. And we said we need to set this as well. So we'll go to our old one, copy that, paste that there. And now that we have those files in there, I want you to do is go ahead and do a git status. So we have 3 files, that's great. Git add, git commit -m, docker run. And we need this, we need a git repo because it's going to create a new one when we run EB init here in a moment. So I'll just do git status, make sure that all worked fine. Great, and we will do EB init. So we're going to choose US East 1, so number 1. We are going to create a new application, so press 2. We are going to stick with the name that we are given here, so hit enter. We are definitely using Docker, so we'll hit yes. We want to use cocommit, sure, so we'll hit Y. We need to select a repo. We are making a new repo, so press 2. Enter the repo's name. This is going to be called study sync external. Make sure you type it right. We are going to want it to be master branch, so hit enter. We don't need to SSH in, that's okay. And so there we go. So now that that is created, I'm just going to go up, double check and make sure that is the case. So we'll make our way over to code commit. And here we have our external repo. So it's all in good shape. So now that that's all set up, we should be able to create a new environment. So we'll do eb create -- single. We will name it pretty much the same. I'm just going to take off the dev part on it. Doesn't matter too much as long as you can remember what you set it to. We'll say no for spot instances. And what we're going to do here is just wait a little bit here. It's nice to see the message, just make sure that it's creating what we want it to create. And this is, yep, a Docker image. So hopefully this works first try. I'm going to make my way back to Docker here. We'll go over here. And while that's going, we can go ahead and terminate this one. We don't need this one anymore. And just to point out, like, look at this. This doesn't contain any of our code. So where is our code? Our code is part of the actual Docker container. That's why we don't see it here, because when we built it, it copied it and put it into the actual container. Whereas in this setup, the Docker file is here, and so we can work with our source code and have it all in one place. So you just have to decide, you know, what workflow works best for you. And, you know, if you can get away with just having a Docker file like that, that's definitely better. And this is creating. I'm just going to go back here and do a refresh. I don't see this new environment yet. Should be called external, right? Study sync external. Oh, here it is. Yeah, because it's a completely new application. That's totally fine. So yeah, I'll see you back here in a moment once this environment is done creating. All right, so our deploy is done, but we have health degraded, and it looks like we have an error here. It turns out Elastic Beanstalk can't authenticate to ECR because we didn't give it permissions to do so. Whereas in Cloud 9, we had pulled that the credentials and stored it in here so that we could read from ECR. So what we need to do is update the instance profile of the actual EC2 instance that runs here. So what we'll need to do is make our way over to IAM. So just type in IAM here. We'll open this in a new tab. On the left-hand side, we'll go to roles. We'll go to EC2 role here for Elastic Beanstalk. We're going to attach permissions. We're going to type in Amazon, EC2, read-only container. We'll attach that policy. So this should allow us to gain access to ECR. And then what we'll do is go back to Cloud 9, and we'll simply do EB deploy. And so what that will do is it will just deploy again, but now it will also update the IAM role, and it should have permissions this time around. So we'll give it a second here to get started. We'll make our way back over to here. We'll do a refresh. And we can see this is in progress, and I'll see you back here momentarily. And our deploy is done. So I'm just going to close these additional tabs here. I'm just going to open up the new tab here. And we are now seeing version 3. If you don't remember, it could be Chrome caching it, but there you go. So we went through a lot of different variations here with Elastic Beanstalk. And, you know, that is a lot of stuff, but it is necessary to go all through these things. So let's just go ahead and clean up what we have. So I'm going to go back all the way to applications. And what we can do is go ahead and just delete these applications. This should terminate all the environments. So we hit delete. And we're going to also delete this application here. We'll say delete. If we click into this, these should be terminating. So our Cloud9 environment, it's not a big issue. It's going to shut down after 30 minutes when we're not in use. For our Elastic containers, we're going to go to code commit. I don't think this is really an issue having these around, so I don't have much motivation to delete them, and we might be using them for the ECS and Fargate tutorials. So we're going to leave these alone, or we're going to leave our code commit code commit and ECR alone. So we'll leave this alone as well. But yeah, that's it for the Elastic Beanstalk walkthrough. So to really understand AWS config, we need to first understand two things. And the first of those two is what is change management. So change management in the context of cloud infrastructure is when we have a formal process to monitor changes, enforce changes, remediate changes. And then the other thing we need to know is compliance as code, which is when we utilize programming to automate the monitoring and enforcing and remediating changes to stay compliant with a compliance program or expected configuration. Which brings us to AWS Config. And AWS Config is a compliance as code framework that allows us to manage change in your AWS account on a per region basis. All right, so now let's take a look at use cases for AWS Config. So when should you use AWS Config? And I would say it's when you want a resource to stay configured in a specific way for compliance, when you want to keep track of configuration changes to a resource, or when you want a list of resources within a region, or when you want to analyze potential security weaknesses and you need detailed historical information. So just down below, I just want to show you an example of an architectural diagram. So imagine you have a rule, and that rule is to make sure that your EC2 instance is configured the correct way. You'll have a Lambda that will actually check to make sure that whatever your configuration is correct. And then we have an example of another AWS configuration rule that's checking an RDS instance, and it's found a problem. And so what it does is it remediates, so it tries to correct the issue. But we'll talk about remediation here in a bit, but there you go. So let's take a look at resource inventory. This is the first feature you're going to encounter on AWS Config because AWS Config is turned off by default. And as soon as you turn it on, it's going to discover all your resources and give you an inventory of all your resources within the region. And this is totally free. And this is a great way to find where your stuff is. So here on the right-hand side, we have a big list of resources. You can see there's a 611 resources within our region here. And you can use the resource inventory to figure out what you have running in an AWS region, search existing or deleted resources recorded by AWS Config, find malicious AWS resources that should not be running within your account. And I have to emphasize that you have to turn this on per region. So, that's something that's really important if you really want to have full visibility. Make sure this is turned on in every region that you're operating in. So now let's take a look at the most important component of AWS Config, which are config rules. And config rules are just AWS Lambdas designed to check if a desired configuration is met on an AWS resource. And there are two types of configuration rules. We have AWS managed rules, and these rules are created by AWS. So you just choose one that you want. And you have custom rules. So you can create and associate a Lambda and define it how you want it to trigger. And so here are the two options there. AWS managed rules and create custom rules, and we're going to look at both of them here in the next slides. So now let's take a look at AWS managed rules, and these are predefined rules by AWS with some level of customization, and there are around 100 plus AWS managed rules to choose from, so you got a lot of options here. All you got to do is go into that managed rules box, type in what you want. So here I'm typing RDS, and you can see there's a lot of rules that you can spin up. There's one that says check whether the RDS instance has backed up enabled, so that's kind of a cool thing. You cannot change the trigger type, but you can change some of the settings such as scope of changes or frequency when we're dealing with managed rules. So here you can see the trigger type is commented out. And we'll look at this in the custom rules, so these will make a little bit more sense in the next one, but I just wanted to point that out. So now let's take a look at custom rules. And with custom rules, we're able to set the trigger type. And so there's two types here, configuration changes and periodic. We're first looking at configuration changes. And what we can do here is change the scope of when evaluation occurs. So when it will actually check the rule to see if things are compliant. The default option is on all changes. So when any resource is changed, created, or deleted, this evaluation will occur. You can specify a very particular resource, and you can add multiple resources on which ones they would happen on, or you can specify tags, okay? And so you just provide a tag there. The other kind of rule is periodic, and so you can change the frequency of how often the evaluation occurs. And so you can just drop this down and choose between 1 hour and 24 hours. Every time evaluation occurs, when it's checking a resource, it does cost money. It is in the fraction of a cent. But the thing is that evaluation could definitely be more cost effective than periodic, especially if periodic it is a lower frequency. So that would be the reason why you'd want to do it. Also, evaluation is a bit better because it's kind of reacting to changes on the resource. So if an EC2 instance has been terminated, then it's going to evaluate it, right? Whereas with custom rules, it's always on a schedule. So there you go. Take a look at the resource timeline, and I really love this feature about AWS Config. But the idea is when you click into a resource, it's possible to see a timeline of changes, and you can see two different kinds of timelines. We can see a configuration timeline, so when changes have been made to the resource, and compliance timeline, so when a resource has become uncompliant with a rule. And so down below here we can see that, and we can literally see exactly when something was compliant and what it was not, and then we can drill down and see what was actually changed. This is super important for compliancy, because if you want to prove that you were compliant at a certain time so that you are not liable, this is what this feature is for. So there you go. Let's take a look at remediation. And remediation is the concept or the action of reversing, stopping, or correcting something. I always say, if you look at the word remediation, just think remedy, because that's where the word remediation comes from, and that helps you make more sense of it. You are applying a remedy to a problem or situation. And so AWS Config allows you to remediate non-compliant resources that are evaluated by AWS Config rules, and you configure a rule to remediate automatically or manually trigger remediation. So there are your two options. And so what you can do is you can choose a remediation action that should happen. So if it was something that was happening automatically, maybe the remediation is to delete the image, take a backup, enable CloudTrail, whatever that option is. But that's a really cool feature to have. So now let's take a look at aggregators, and I want to pose a question to you. What if I had multiple AWS accounts and regions, and I want to aggregate those AWS config information in a single account? And that's where aggregator comes into play, because what it can do is it can actually collect all your AWS config data from multiple accounts and regions. So all you do there is you specify the individual account IDs, or you can say for the entire organization. And then you just specify the regions. So you can say, I just want these particular regions, or you can say include all future regions. And aggregator will replicate the data from the source account to the aggregate account. So the data is going to be available in both places, but it's going to be replicated into your aggregate account, okay? And the aggregator has three subcategories. We have rules, resources, and authorization. So looking at rules first, rules represent your desired configuration settings, and you will see rules across regions and source accounts. And so here's just an example of something that we could, this is an example of a rule. I'm just showing you a managed rule here. We already know what rules are, I'm just redefining it here. Then you have resources, which are AWS resources within your AWS account. So that could be EC2, Kinesis pipelines, RDS databases, and you will see resources across regions and source accounts. So that's really useful. And then you have authorization, and this grants permission to the aggregator account and the regions to collect AWS configuration and compliance data, okay? So there it's just saying who is authorized to share that information. So there you go. So let's take a look at conformance packs, and these are a collection of AWS config rules and remediation actions that can be easily deployed as a single entity in an account in a region or across an AWS organization. And packs are created by authoring YAML templates that contains the list of AWS config managed or custom rules and remediation actions, and you deploy them via the AWS console or AWS CLI. And when they say YAML templates, what they really mean is a CloudFormation template. I like how AWS will say something and then you just find out it's something underneath. But that's great that they're CloudFormation templates because they're easy to read. And so AWS actually has sample performance pack templates, which are actually really useful to use. You can find it via the AWS documentation, but I just want to show you the names if you want to go look them up yourself. So the first is AWS Control Tower Detective Guardrails Conformance Pack. We have operational best practices for Amazon DynamoDB. We have operational best practices for Amazon S3. We have operational best practices for AWS IAM, best practices for the Center of Internet Security, NIST CSF, PCI DSS, templates with remediation action, and then you can, it has an example of a custom conformance pack. So there you go. One of my favorite features of AWS Config, and I hope you use it soon. So let's take a look at advanced queries for AWS Config, and these allow you to write SQL queries to quickly find resources within your AWS account, and you can query for resources cross-region or cross-account. So here on the left-hand side, what we have is a bunch of pre-made SQL queries. So if you're wondering, what do you write? Well, you can just go click on one of those, and what it will do is open up this SQL editor that already is pre-populated, and you just hit run, and there you can find your resources, and you can export it as JSON or CSV. Very, very cool feature to have. So there you go. Hey, this is Andrew Brown from Exam Pro, and we're looking at the AWS Config cheat sheet. So Config is a compliance as code framework that allows you to manage change in your AWS account on a per region basis. And you should use AWS Config when you want a resource to stay configured a specific way for compliance, want to keep track of configuration changes to resources, want a list of all the resources within a region, want to analyze potential security weaknesses, or you need detailed historical information. AWS Config is turned off by default. You can turn it on for free per region, and it will discover resources within that region and will create a resource inventory. A resource inventory is a list of all running AWS services and resources running in the region. AWS config rules are just AWS lambdas designed to check if a desired configuration is met on an AWS resource. So config rules are basically the backbone of config. There are two types of config rules. We got AWS managed rules, where these are ones that are created by AWS for you and they're ready to use. And you have custom rules. You can create and associate a lambda and then define how it's triggered. A config rule is triggered when there is a configuration change or it's either periodic. So if it's configuration change, then the custom rule or the rule is just going to evaluate when a resource is created, updated, or modified. For period, it's evaluated on a defined interval. So 1 hour, 3 hours, 6 hours, 12 hours, 24 hours. Configuration change can be a lot more cost effective because it's only it's only evaluated when changed. Whereas period, if it's every 1 hour, it can get expensive. You have a lot of config rules. It's very cheap service, but if you have a lot of them, it can get expensive. You have something called the resource timeline. So when you click onto a resource within AWS Config, it's possible to see a timeline of changes. You can see two different kinds of timelines. You have configuration timeline, so when changes have been made to the resource, and compliance timeline, so when a resource has become uncompliant with a rule, and that's like over time, so it's very, very useful. So remediation is the act of reversing, stopping, or correcting something. I like to say to remedy a problem. You can configure a rule to remediate automatically or have it manually triggered, so you'd have to press a button for it to happen. You can choose a remediation action that you want to occur. So you could say the remediation action is just to shut down the EC2 instance. AWS Config has this thing called aggregator, and it allows you to collect all AWS config data from multiple accounts and regions. An aggregator will replicate data from a source account to an aggregate account. The aggregator has three subcategories: rules, resources, and authorizations. So rules, it just means all your rules in one place. Resources is all your resources in one place. Authorizations is granting permission to the aggregator accounts and the regions to collect it into one place. So permissions to say, hey, can you send this data over to the aggregate account? And then we have conformance packs. So this is a collection of AWS config rules and remediation actions that can be easily deployed as a single entity in an account, in a region, or across an AWS organization. Packs are created by authoring YAML templates. Surprise, surprise, they just happen to be CloudFormation templates underneath that contains a list of AWS config managed or custom rules and remediation actions. AWS has really, really good sample conformance pack templates. Go check them out. You can even use them for production use cases, or just modify them if you need to. Deploy by using AWS Config Console or the AWS CLI. And the last thing here is advanced queries. This allows you to write SQL queries to quickly find resources within your AWS account. It can query for resources cross-region and cross-account. That's working with the resource inventory. And there you go.